Chapter 18, Tangents and Intersecting Chords. If a circle and a straight line are drawn in a plane, then with respect to each other, they may have one of the following three positions. First position, circle and a straight line. Okay, and second position, circle and the straight line passes through the circle. It meets the circle in 2 points. Okay, and the third position, circle and it touches the straight line at a particular point. Okay, these are the three positions when a circle and a straight line are drawn in a plane. The straight line which cuts the circle at 2 points is called secant of a circle, and the circle which touches the circle at 1 point is called the tangent of the circle. So, in the given figure, thus EF is a tangent at the point P. P is a point on the circle. This point P is called a point of contact. Let us learn some important theorems related to tangents and circles. First theorem, you can see a circle, center O, radius OP, and here I marked a point P. At that point I drew a tangent. AB is a tangent to the circle at the point P. Now the theorem is the tangent at any point of the circle and the radius of the circle at the point of contact is perpendicular to each other. Okay, that means OP is perpendicular to AB. What is the statement of the theorem? The tangent at any point of a circle, you can mark the point anywhere, okay, on the circle, and the tangent drawn at that point and the radius through this point are perpendicular to each other. This is the statement. How can we prove this theorem? Let us check by plotting another point on this tangent. Okay, and join this OQ. And this is another distance OP. From the center to the point P at the point of contact, this is the distance, and OQ is another distance from the center to the same tangent AB. Okay, which one is greater or which one is smaller? We can say that this length OP is less than OB, no? Since this point is outside the circle and this is on the circle. So clearly the length OP is less than OQ. Similarly, it can be shown that out of all the line segments drawn from the center to the line, the perpendicular is the smallest one. Perpendicular distance will be the smallest one. When we measure the distance from a particular point to the line, perpendicular distance is the smallest one. So we can say that OP is perpendicular to AB. The shortest line segment drawn from the given point to the given line, perpendicular to the line, is the shortest. So we can say OP is perpendicular to AB. This is the first theorem. What is the first theorem? Tangent and radius are perpendicular to each other. Understood? And the next one, or we can discuss the corollary also. And always remember, no tangent can be drawn to a circle through a point inside the circle. If we take inside point A, and from this inside point we can't draw a tangent to the circle. Also, one and only one tangent can be drawn through a point on the circumference of a circle. Suppose I mark a point here. So how many tangents we can draw? Only one. For this point also, how many tangents we can draw? Only one tangent. And also from an exterior point, can you say how many tangents we can draw to the circle? Suppose this is an exterior point. How many tangents we can draw to this point? Here is one. And what about this point? From this exterior point we can draw one more tangent. So from an exterior point, outside point of the circle, we can draw two tangents. Only two tangents. Only two tangents we can draw to the circle from an external point P. Let P be an external point. This is the first one and this is the second one. Only two tangents we can draw. Now the corollary. If two tangents are drawn to a circle from an exterior point which lies outside the circle, exterior point means which lies outside the circle, the tangents are equal in length. If two tangents are drawn from an external point, the two tangents are equal. We can say AP, tangent AP is equal to tangent BP. Okay. Second point is tangents subtend equal angles at the center. You can see the first theorem. What is the first theorem we have? Tangent and radius make right angle. And this also right angle. If we join the distance O and P, you can see that these two triangles are congruent. Look at this. Angle A and B 90 degree. OA and OB radii of the circle. And OP is equal to OP, common side. So that we can say that the length of the congruent triangles are congruent always. So we can say AP is equal to BP and they subtend equal angles at the center. So angle subtended by the tangent AP is angle AOP and the angle subtended by tangent BP is angle BOP. They are equal. Always they are equal. Since we can prove these two triangles are congruent, so the corresponding parts of congruent triangles are congruent, hence we can write this. And the third point is the tangents are equally inclined to the line joining the point and center of the circle. If we draw a line segment joining the point and the center, these two tangents are equally inclined. From this, the inclination is same. That means angle APO is equal to angle BPO. Okay, these are the main points to remember. Always remember this. For two tangents from an external point, they are of equal length. They subtend equal angles at the center. These two angles are equal and these two angles are also equal. They are equally inclined to the line segment joining center and the particular point. Understood? Theorem 13 is the angle between a tangent and a chord through the point of contact is equal to an angle in the alternate segment. Let us draw a circle here and a tangent at the point P. This is the tangent. AP is tangent. And if we mark a chord passing through the point of contact. This is the point of contact. So let us draw a chord. BP is a chord. This is the tangent and this is a chord. And the angle between the tangent and a chord. Let x degree be the angle between the tangent and a chord. That is equal to angle in the alternate segment. This is the segment, no? So this portion is the alternate segment. If we mark any point here we can mark anywhere. Suppose D is a point. So angle in the alternate segment is PAB. PAD is also x degree. Or we can mark the point as C. Then PCB also x degree. Or we can consider this point E. Then PEB also x degree. Understood? Angle in the alternate segment and the angle between a chord and a tangent are always equal. Similarly, P and DP tangent portion and the chord same PB itself, and the angle between the tangent and chord, this portion tangent and a chord, if we take it as y degree, then angle in the alternate segment, this is the alternate segment, no? This is the angular portion. So this is the alternate segment. If we mark any point in the alternate segment, that angle is also equal to the angle between the tangent and the chord. Understood? This is the theorem. This we can prove also. In page 277 the proof is there. Okay. How can we prove the theorem? First we join AR passing through the center O. AR is the diameter, and join this RB. AB is the chord and PQ is the tangent. I mark this portion as y degree. So we have to prove that this also y degree. How can we prove this? Okay. First we have to join RB. Then we know that angle in a semicircle is 90 degree. That is angle ARB is 90 degree. Also angle RAB plus angle BAQ is 90 degree. Angle between tangent and the radius is 90 degree. Angle RAQ is 90 degree. Similarly, what is the sum of these two angles? One of the angle in the triangle is 90 degree, so sum of the other two is also 90 degree. That is angle ARB plus angle RAB is equal to 90 degree. Okay. This is the first equation. ARB plus, this is B, okay. RAB 90 degree first equation, and you know that RAQ 90 degree. RAQ can be divided into two parts, RAB and BAQ. Okay. Angle RAB plus angle BAQ is equal to 90 degree. This is the second equation. So on comparing these two equations, RAB is common for these two equations. Okay. Sum of them is 90 degree. Here also sum of these two 90 degree. Which implies from 1 and 2 implies angle ARB is equal to angle BAQ. Angle ARB is equal to angle BAQ. This is angle BAQ. Angle between the tangent and the chord. This is angle in the alternate segment. That is, and hence prove the theorem. That is, angle between tangent and chord is equal to angle in the alternate segment. Angle between the tangent and chord is equal to angle in the alternate segment. You write the statement of the theorem. Okay? Understood? Solve the problems from exercise 18A. First question. The radius of a circle is 8 centimeter. So, let the radius be R, 8 centimeter. Calculate the length of tangent drawn to this circle from a point at a distance of 10 centimeter from its center. That is, distance from the center is 10 centimeter. We have to calculate the length of the tangent. Let us do this problem. Let us draw a rough diagram. Here is a circle of radius R centimeter, and let us draw a tangent. This is the tangent. We don't know the length of the tangent. Let it be x centimeter, and let us complete this radius and the distance from the center to this point from which the tangent is drawn to the circle. This distance is given 10 centimeter. Radius is 8 centimeter. And how can we find the length of the tangent? Length of the tangent? Yes, we can apply Pythagoras theorem. Why? Angle between radius of a circle and tangent always 90 degree. R is perpendicular to X by the theorem. So this is a right angled triangle. Apply Pythagoras theorem. So how can we relate this? 90 degrees this one, no? So which one is hypotenuse? Side opposite to 90 degree. That is distance is the hypotenuse, and this is one side and this one other side. So we can write r square plus x square equal d square. D is the hypotenuse here. 8 square plus x square is 10 square. What is the square of 8? 64 plus x square gives 100. X square is 100 minus 64, 36. X square is 36. So can you say what is the value of x? Yes, x is the square root of 36. That is 6 centimeter. Thus we obtained the value of length of the tangent. What is the length of the tangent? It's 6 centimeter. Understood? Therefore, x equal to 6 centimeter. The length of the tangent is 6 centimeter. Okay, write it in your notebook. Now let us do the second problem. In second question, O is the center of the circle, AB is the tangent at B. At this point B. AB is 15 centimeter. So length of the tangent is given 15 centimeter. And AC 7.5 centimeter. A to C. This portion is 7 centimeter. Sorry, 7.5 centimeter. Calculate the radius of the circle. Let the radius be R. And what about this length OC? That is also the radius of the circle, no? So we can mark OC, length OC as R centimeter. So let the radius be R. Therefore, OB equal OC equal R centimeter. Now we can apply Pythagoras theorem. Why we apply Pythagoras theorem here? It's a right angle triangle. OB is perpendicular to tangent AB by the theorem. Therefore, in right angled triangle, OB square plus AB square is equal to OA square. Okay, here we know that right angle is angle B. So side opposite to right angle is always the hypotenuse. So this is the triangle OBA. So OA is the hypotenuse. Okay, now we don't know the length, total length of OA. So we have to replace the values. R square plus 15 square equal to OA. OA means the sum of OC and CA, the whole square. Okay, that is R square plus 15 square. What is the square of 15? 225. 15 into 15. OC, that is R. R plus AC, 7.5 square. So right side is the expansion of A plus B the whole square. Do you remember what is A plus B the whole square? Yes, A plus B the whole square. Sum of two numbers. When we have to find the square of the sum, we have to use this identity. First number square, second number square plus product, twice the product of first term and second term. Okay, apply this. R square plus 225 gives R square plus 7.5 square plus 2 into R into 7.5. Okay. We can cancel out R square from both sides. When we write r square to the left side, r square minus r square is 0. Then 225 equals 7.5 square. 56.25 plus 2 into 7.5. 15r. Now 15r equal 225 minus 56.25. Subtract 225.00, 56.25. 168.75 gives 15r. So how can we find the radius? 168.75 by 15. 115 is 15, remainder 1, 18. 115 is 15, remainder 3, 37. 30. 75. 5. So 11.25 is the radius of the circle. Okay, understood? Third is not in your syllabus. Fourth also, when the two circles touches internally or externally, that is not in your syllabus. Sixth one also not in your syllabus. Cancel it out. Now the fifth question. Fifth question is, two circles of radii 5 cm and 3 cm are concentric. Concentric means circles with a common center. So this is the center of two circles. First one with radius 5 cm. So the larger one, and the smaller one 3 cm. Radius 3 cm. Calculate the length of a chord of outer circle which touches the inner circle. So we have to find the chord of larger circle. It should touch the smaller circle. So you can say this is a tangent to the smaller circle. Chord of the outer circle. Circle will be the tangent to the smaller circle. Okay, so we can say this radius, angle between radius and tangent is always 90 degree. Let us complete the right angle triangle. You know this angle is 90 degree, okay? And let us complete this. So, this is the chord of the larger circle and this is a radius. Okay, distance or a line segment drawn from the center to the chord always bisect the chord. Okay, now we can take these two portions are equal. This is x and this is also x. Let us complete this triangle. This is O, A, B, C. So we know that OC is perpendicular to AB by the theorem. Tangent is always perpendicular to the radius and OA is equal to 5 cm, radius of the larger circle. OC is the radius of the smaller circle, 3 cm. And we can apply Pythagoras theorem. How can we solve this problem? Yes, OC square plus AC square equal to this radius, that is OA square. Side opposite to right angle is the hypotenuse. Now apply the values. OC is 3 square, AC we don't know, that is x. OA is the radius of the larger circle, 5 square. 9 plus x square gives 25. X square is 25 minus 9, that is 16. So x is square root of 16, 4 centimeter. So the half portion of the tangent is 4 centimeter. Therefore, can you say what is the length AB? Yes, 4 plus 4, 8 centimeter. Therefore, the length of the chord of larger circle is 8 centimeter. Length of the chord of the larger circle is 8 cm. Of the chord of the larger circle is 8 centimeter. Understood this problem? Okay. Do question 7 homework. Now the 9th problem. You can see a diagram in which a triangle ABC is there and a circle which touches all the sides of the triangle. We have to prove that AP plus BQ plus CR is equal to BP plus CQ plus AR. Also we have to show that the sum of AP plus BQ plus CR is half of the perimeter of the triangle ABC. First, what is the perimeter of triangle ABC? That is the sum of AB plus BC plus AC. And we can write this like AB as AP plus PB and BC as BQ plus QC. Also, this AC as AR plus CR. Okay, in this way we can write it. We know that perimeter of a triangle is the sum of 3 sides. Okay, now we can substitute this. First of all, AP and AR are tangents to the same circle from the point A. Yes or no? AP and AR are tangent to the same circle. This tangent meet at the point P and this tangent meet at the point R. So what about the property of tangents drawn to the circle? From an external point, a common point? Yes, they are of equal length. So these two are equal length. AP is equal to AR. What is the reason? Yes, tangents from point point A. Similarly, what about BP and BQ? Are they equal? Yes, BQ. BQ is tangent to the circle which touches the side, no? Touches the circle, no? At Q? Yes. And P. BP touches the circle at P. So BQ equal BP. Same reason. Okay. From point B. Similarly, third one. CR and CQ. Are they equal? Yes. CR equal CQ. Same reason from tangents from the point C. Okay. Now, let us add the 3 equations so that we can prove the first statement. Add the left side and right side. What is the left side? AP plus BQ plus CR. I wrote these 3 to the left side. You also write like that. And the right side AR, BP and CQ is equal to AR plus BP plus CQ. Hence we proved the first part. Okay. Hence proved. First part we proved. Understood? Very easy. Just take the tangents. Length of the tangents from a common point is always equal and add all the 3 equations to obtain the first proof. Now, what about the second one? Let us solve this. To prove the second part, we know the perimeter is AB plus BC plus AC. That is the sum of AP, PB, BQ, QC, AR and CR. Let us replace AP plus BQ plus CR. AP plus BQ plus CR. AP plus BQ plus CR plus remaining portion PB plus QC plus AR equal the perimeter. Now AP plus BQ plus CR and PB plus QC plus AR are equal, no? So let us replace AP plus BQ plus CR plus again AP plus BQ plus CR equal perimeter. Understood? How can we write this? Since AP plus BQ plus CR is equal to PB plus QC plus AR. These two sums are equal. that we proved already. So we can replace. Okay. Now twice, 2 times this group is repeating, no? Yes. Twice the sum of AP plus BQ plus CR gives the perimeter. P means perimeter. Okay. So what is AP plus BQ plus CR only? Twice it is perimeter. So what is the sum? Yes, we have to write this 2 to the right side as 1 by 2 into perimeter. That is the half of perimeter. 2 times AP plus BQ plus CR gives the perimeter. So 1 time AP plus BQ plus CR gives half of the perimeter. Hence we proved that also. Understood this proof? Very easy. Just know what is perimeter of triangle and what is the property of length of tangents from an external point. Now let us solve the 16th problem. 16th problem, there is a right angular triangle with AB 12 cm, AC 13 cm. A circle with center O has been inscribed inside the circle. So that this BC, AB and AC are tangents to the circle from the points ABC. Okay. And calculate the value of x, the radius of the inscribed circle. So this is x and this is also x. All these are radius. Okay. We have to calculate the value of x. You can see this is x and so this portion also x. This is x, so this portion also x. By using this we can find out. For this is a right angle triangle, we can apply Pythagoras theorem also. Let us complete this. Okay. Now we can find BC. Square root of AC square minus AB square. Pythagoras theorem. Calculate the value of BC, that is 13 square minus 12 square. That's equal to 25. Square root of 25 is 5 centimeters. So the total length is 5 centimeter. So we have to find the circumradius. Okay. So that calculate the radius of the inscribed circle, not circumradius, inscribed circle. Radius, let radius of the circle be x centimeter. So how can we write this length in terms of x? This portion we can divide this. This is total is 12. Let us mark this is D and this is E and F. So this total length is 5 centimeter. So what about the length of CD? It's a 5 minus x. BD is equal to FO. Since this is 90 degree and this also 90, this portion 90, that's why it's a part of a rectangle, that's why, or a square like. So BD equal to FO is equal to x. Therefore, DC equal to BC minus BD, that is 5 minus x. And what about this CF and CD? Are they equal? Yes, they are the tangents to the same circle from the external point. Here write the length of CE also 5 minus x. Similarly, this portion FB is x units. Okay. Now what about this portion? This total length is 12 centimeters. So AF is 12 minus x. AF is 12 minus x. And we can say that this AF and AE are equal. They are tangents to the same circle from the same point. AF equal to AE. Tangents from A. Therefore, AE also equal to 12 minus x. Understood? First part DC and CE are 5 minus x and this portion is 12 minus x. But we know the total length of AC as 13 centimeter. So we can use that sum to get the value of x. Okay, let us solve this. AC is 13 centimeter given in the question. AC means the sum of AE and EC. That is 13. What is the length AE? Yes, 12 minus x plus EC is 5 minus x gives 13. That is 17 minus 2x equal 13. 17 minus 13 is 2x. 4 equal to x or x equal 4 by 2, 2 centimeter. That is the radius of the circle is 2 centimeter. Radius is 2 centimeter. Understood this problem? Just take the Pythagoras theorem to find the third side and write this AC in terms of the tangents. These two portions are equal, these two portions are equal, and the sum gives 13. Okay, understood these problems? Do the homeworks.